everyone, this is Harsimran and today I'm going to demonstrate the implementation of a smart home system using IoT devices and MQTT communication in Cisco Packet Tracer. So the main objective of this project is how to show how multiple smart devices communicate efficiently with each other using a lightweight protocol and be controlled logically and remotely. So in this setup, I have used several devices like this SBC-PT. This acts as a MQTT broker, which is the central communication hub. Then the MCU is used for control and interaction with devices. Then I've used these three IoT devices: this one fan, smoke detector, and light. And then this laptop is used for monitoring, publishing messages, and controlling devices through a web interface. Then this one, home gateway, this provides wireless connectivity and also act as a IoT server. So this entire system represents real world IoT applications. Then the purpose of using MQTT in this project is to enable efficient communication using a publish subscribe model. Instead of devices communicating directly with each other, they communicate through the broker, which improves scalability and flexibility. So these are smart devices, so we don't need to connect it via cable, so they will communicate wirelessly. But these three, we need to connect it to this home gateway via carbon cable. So if you go SBC, it doesn't really have an Ethernet port, so what you need to do is go here, physical tab, and turn it off, and drag this module here, and then turn it on again, and then you'll get a Ethernet port. You need to do the same with MCU board also, and then you get one Ethernet port on both of these boards, and you can use carbon cable to connect it to home gateway. Then again, connect laptop to home gateway also, and we don't need to connect these three. Then the next step is to configure it. Go to settings, make sure that we are using DHCP. We need to enable DHCP, and here is the default gateway is 192.168.251. And then go to Ethernet, enable DHCP, and this is our IP address for SBC board. Then go to Wi-Fi. So you need to set SSID. I kept it home gateway, it's the default one. You can name it anything. Then under authentication, select this WPA2PSK and enter password. You can set any password, and then DHCP should be enabled. Then yeah, that's it for SBC board. Then go to MCU config. Again, make sure DHCP is enabled. Ethernet, again DHCP, and yeah, here the IP is 192.168.255. The IP of SBC was 192.168.272.5.109. So we can say that every device here in this setup belongs to the same network. So make sure that everything belongs to the same network, otherwise it won't work. Then laptop config, again DHCP, fast Ethernet, DHCP, it belongs to the same network. That's it. And now fan config, setting, DHCP enabled, wireless, again same SSID. Then under authentication, choose this one, set the same password, and DHCP is enabled already, and it belongs to the same IP address. Light also config. So we need to do the same thing with each device here. Okay, so now we have configured everything. We enabled DHCP, and every device belongs to the same network. And DHCP is enabled here also. Okay, so we have configured it. So now the next step is to enable MQTT. So go to SBC. This is this board is going to act as a MQTT broker. For that, go to programming. From here, you need to choose new, and then you will get an option from where you need to choose MQTT broker Python file. It's already there. You need to choose from the drop down and then create, and then install it on desktop and run. So it's running, and when you go to desktop, you'll find this MQTT broker here. Open it and make sure it's on. You can even add username and password. It's completely optional. And make sure it's running. Do not close the window, and then go to plan, and then after coming here, go to advanced. After advanced, go to IO input output config, and you need to check this checkbox here, the second one. You'll see you'll get this new desktop tab when you check this. So go here desktop, then go to user apps manager, then available. So I've already installed this MQTT client, but if it's your first time, then you'll find MQTT client here. You need to install it. Once installed, go back and you'll find it here in the desktop. Double click it to open, and here you need to enter the SBC IP address that you can find here, config and then Ethernet. So this one, 192.168.25109. 192. And then the username and password, and connect. Okay, so we need to do the same with all the three IoT devices and laptop. Um, you'll notice one thing that in laptop there is no advanced button here, so you don't activate it. You can just simply go to desktop, and here you can find user app manager. From here you can download MQTT client. So now you see that this laptop is going to publish all the messages received from these IoT devices. So under in laptop, under this section subscriptions, write home, and this is the wildcard, means it will publish all messages received from our IoT devices. Then subscribe, and then you'll see the messages here. Then in here in IoT devices, go to publish, write home, like IoT 0 is fan. So we can write home, fan, then payload, let's say on, then publish. And see, you get this message here, topic home slash fan, payload on. And if pressing off, it's off. You can do the same with other devices also. IoT2 is light. IoT2 is light on the topic home slash light, payload on.
Our third device, it's it's a smoke detector. So say zero. So now uh, this demonstrates that we are able to publish messages from our IoT devices to our laptop. We're able to send messages, and our laptop also able to publish all the messages received from our IoT devices. It shows that we are able to do MQTT communication correctly. Now the next thing is, uh, if we really want to control these devices here, means if we will want to turn this fan on or off, or this light on or off, we can actually control it. But for that, we need to make few changes in our setup. So what you need to do is go here, fan, then config, settings. And if you scroll down, you'll find this section IoT server. Here, select this home gateway. And after this, go to programming, select this script and run. And you'll see this message, starting ceiling fan. You need to do the same with all these three. Advanced, then config, settings, home server, and program, run. Uh, Starting light, then smoke detector, setting, and run. So smoke detector, starting smoke detector. So once it is done, what you need to do is go to laptop, then you can close this, then web browser, and here you need to enter, yeah, the default gateway, which is 192.168.2.5.1 in my case. And here enter your username and password. If it's our first time logging in, then it will first ask you to sign in, and there you can set your username and password and submit. And you can see these IoT devices here, which are currently active, means it's on. So from here we can control our devices like this IoT tool, which is light. It's currently on, you can make it on, off, or dim, or on. Similarly, this fan, low, high, low, high, off. So that's it. This is how we can control our devices. We can even control our smoke detector, but for that we need something to produce or to change the smoke level. For that we can um, use this old car here, place it near the smoke detector, and you can see that initially the level will be zero, and to make it produce smoke you just need to press alt key and then click on the car, and it will produce smoke. And you can see here on the IoT server dashboard that the level of smoke is changing. So now we know that smoke detector is actually working. Similarly, we can add more devices, like I added this garage door here. So you just need to go to config, settings, make sure that DHCP is enabled, then go to wireless. Under authentication, enable this WPA2 option and then add your password. Make sure that DHCP is enabled. Then go back to settings and choose this home gateway option under IoT server. And now it's connected to our home gateway. Now go back to your IoT server dashboard, refresh it, and you can see that this garage door is showing here. But to make it work,
You need to go to advanced first, then programming. Select this script and run it. Once it's running, go back to your IoT server dashboard and now you can control it from here. So in conclusion, we can say this project demonstrates how MQTT enables efficient real-time communication between IoT devices. It highlights the advantages of using a centralized broker, wireless connectivity, and scalable architecture for smart home automation systems. Thank you.